Over 50 years have passed since humanity last walked on the moon during the Apollo 17 mission. It is easy to assume that because we accomplished this in the 1970s, going back today should be a simple repetition of past successes. But the strategy has shifted. The Apollo missions were designed to leave temporary footprints and plant flags. The Artemis program aims to build permanent, sustainable infrastructure on the lunar surface. Supporting a permanent lunar presence requires significantly heavier hardware. The Space Launch System is the most powerful rocket ever operated, designed to lift an Orion capsule that contains 30% more habitable volume than its Apollo predecessor. Inside that capsule is a 4-person crew: Commander Reed Wiseman, pilot Victor Glover, and mission specialists Christina Koch and Jeremy Hansen. Before this crew, or any future crew, can attempt a lunar landing, they have to prove that modern humans and this new technology can actually survive the radiation and physics of deep space. Artemis II is a high-stakes dress rehearsal, designed to ensure the hardware works under actual stress before committing to a permanent lunar outpost. This diagram shows the Orion capsule moving in an elongated, highly elliptical path around Earth. Instead of shooting straight for the moon after launch, the spacecraft intentionally spends its first day in this phasing orbit. This allows the crew to conduct a 24-hour stress test of Orion's life support systems. They monitor the internal atmospheric pressure and test the carbon dioxide scrubbers to ensure the air remains breathable as their activity levels fluctuate. They also test a new optical laser communication system. Instead of Apollo's radio frequencies, these lasers transmit high-definition video and massive data back to Earth at up to 260 megabits per second. Keeping the spacecraft close to Earth during these initial tests provides a safety margin. If the life support or communications hardware fails, the crew can execute a rapid abort and naturally re-enter the atmosphere within a single orbit. Only after mission control confirms every system is functioning perfectly does the spacecraft fire its main engine for the translunar injection burn, committing the crew to deep space. This figure-8 flight path is a free return trajectory, looping around the moon's far side without orbiting. The moon's gravity acts as a slingshot, hurling the spacecraft back toward Earth, ensuring a safe return even if propulsion fails. At the apex of this loop, the crew travels roughly 4,600 miles beyond the lunar surface. That officially breaks the human distance record set by the Apollo 13 crew in 1970. As they navigated this remote stretch of space, Commander Wiseman radioed mission control with a request to name a newly observed lunar crater, Integrity, in honor of their spacecraft. He grew emotional as he requested a second crater be named Carol, after his late wife. As his voice broke, the rest of the crew gathered around him for a zero-gravity hug. At humanity's furthest physical distance from Earth, the technical checklists briefly stop, leaving 4 people holding each other in the center of the cabin. The final phase of the mission begins as the capsule hits the Earth's atmosphere at 25,000 miles per hour. Returning at lunar velocity generates extreme friction. The air compressing in front of the spacecraft heats the exterior to over 5,000 degrees Fahrenheit, testing the limits of the Avcoat heat shield. During the uncrewed Artemis I flight, a shallow skip entry profile allowed trapped gases to build up inside the heat shield, causing chunks of the material to crack and break off. This diagram compares the previous shallow skip entry with the steeper lofted entry. NASA chose this steeper plunge to solve the heat shield problem. It forces the shield to burn away through pyrolysis, releasing gases that push superheated plasma away from the crew module. The heat shield holds together, allowing the spacecraft to slow down enough to deploy its parachutes and safely splash down in the Pacific Ocean. By surviving this 10-day gauntlet, the Artemis II mission proves the technology and human endurance required to build a permanent lunar base and eventually reach Mars.